So this is question alien dictionary on the GFG. So what's given in the question, firstly I describe you, and this is a very great question there. So since when we are talking about the genuine order or normal order for the alphabet, so it is like A B C D until the XYZ. Okay, so this is the simple normal order as we usually study from the past there. But in this question there it is saying that there are some aliens, and we have to write the ordering of alphabets according to them. But unlike since there are aliens, so they are following a different order, so we are writing this. So how to do this part? So in the question there are the sum of the keywords, so there are the sum of things we have given here. Firstly I have to copy this part so as to explain this in here. Okay, so let's say this is our string there, and there's a one thing that is nothing but the n, that is simply the total number of words there. So this is nothing but the 5 there, and there's another thing that is nothing but the k, so that is the 4. Okay, so what it means, n is nothing but the words there. Let's I have to write this part there. This is for the words and this is for the alphabet. So we have to see there a total number of unique alphabet means A, B, C and D. So that's why k is equal to 4, and there's a 5 words. Okay, so now what is given here? So here the aliens give us the string there, and from which we have to derive what is the ordering for according to aliens. Mean when we have to find the words in dictionary, so what it may be A, then C, then B, then B, or we can say B, then D, can C or A, many of the possibilities. This is something unusual that we normally read. Okay, so what we need to, we have to simply find what is the ordering according to aliens. So now how to do this part here? Okay, we can also do the dry run for this part, so to understand very well. Okay, so see, firstly we are giving at every step we have to figure out the what is the ordering of the characters there, and so we are given the shorter dictionary according to alien language there. Okay, so what's the idea behind this? Since we know one thing there, we have basic idea behind this, we have to simply compare, we can say simply compare adjacent words there. Okay, simply compare adjacent words, and if we are to finding what is the first different character there. Okay, and after it, so basically it gives me the, we can say just wait a second, so it gives me the correct order there. Okay, so that's the thing there. I have to do the dry run for this part. So how to do this? So there's, it is given me that B, A, and then so how to do this part here? See, if I'm discussing this, so if I'm comparing these two things, so what are the things given here? It is nothing but the B, then A. Okay, and what's the other thing, other word? It is writing then A, then B, then C, then D. Okay, we know one thing that when we have to do finding the what are the small element, small word behind these, or we can say see graphically small words, so how to differentiate these? So we have to simply traverse along this word and this word, and whatever the first different character we have to find, this can give me the order, which is the shorter or which is the bigger. Okay, so let's say we are standing at this position and we are standing at this position, so we see let's use this arrow there, that must be understandable there. Okay, so this is our B from here and this is A from here. Okay, so these are the different, and this comes before this. So what it means, it suggests me that there should be the B is less than A, means B should comes before A. Okay, so this gives me the ordering that B comes before A. Okay, so keep reminding this thing. Now come for this, if I are talking about these two adjacent, so what are the things given here? So here the string word become A, B, then C, then D, and what's the other word? It is nothing but the A, then B, then C, then A. Okay, so we are standing at here. Okay, we are standing at this and this. Okay, so this is similar, so this doesn't give me the any of the order. Come to the next, this again the same. Come to the C, this again the same. When we come to this, these are the different. Okay, so this means since ABCD comes before ABCA, so that means we can say that D is less than A. Okay, according to Aliens dictionary, means D should come before A. Okay, like already we also can side by side write this thing, like what are the order we can find from this data. So there's a B should come before A, means B should come before A. Okay, now we see D should comes before A, so let's say D has to write before A. Okay, now we have to see from this and this string there. So there's a and C as a different, it means there's a is less than C, means A should come before C. Okay, so this gives me idea relation between A and C. Now come to this, C and C same, A and A same, B and D are different. This gives me the relation between B and D. So B is less than D, and we already write B less than D, means so that so by this we get that this is the order according to Alien dictionary. Okay, so like this is our answer, so we need to find these things there. Okay, so one thing, like what's the thing or what's the like approach we have to doing here, like how to do this part, because okay, so like how to do this. So see, I'm writing the some kind of things there. See, first of all I have to compare is between the adjacent string or adjacent words, so that it gives me the relation between the characters. Okay, so this is the first thing there. This is used to me like this, simply nothing but the gives me the relation, means when we know one thing there, like whenever there's in the question it is asking me something comes before something, so it basically gives me the idea of the topological sort. Okay, means whenever in this question it is writing me let some things before something, like okay, so comes there, like we know we have to compare this part. By this we have to compare, we see that B should comes before A, so it gives me, it is like, can we write this like there is a B and like let's say there is a and we can say there is, let's say if B should comes before, so there must be a directed graph between them, so that after writing all of the relation, all of the edges between all of the characters, we can write a summary way that what that is our the required ordering. Okay, so like how to do this part here, so this gives me the basic idea, like what is the thing till now we are using for it. So this is nothing but the topo sort, we are doing something topo sort because we have to find something before something, for which we are to using this. Okay, one thing again, like we are so we can treat this as a graph question where we have to using our 0 1 2 3 nodes. So we can, what we can say here, we have to treat our alphabets as numbers. Okay, means 0 1 2 3 and so on there. Okay, so we have to find the this ordering of the characters using the topo sort. Okay, and like I can again explain you like how to do this part when we are standing comparing this. Okay, so this B is comes to A, so it means it gives me the idea, like I again the draw part here. So see, there's a B and that comes before A, so let's say this is B and this comes before A. Okay, now comparison this between this. Okay, A B and C are same, D and A are different, that gives me idea that D should comes before A. Okay, let's say we can say there is a D that comes before A. Okay, till now we don't get idea behind relation between B and D, like who comes before. Okay, now comparing between these A and C, it means A should comes before C, so we can say A should comes before C. Okay, now comparing this CA B is comes before D, now we get idea that B should comes before D, like these contains also again the relation there. Okay, so what we can say, this is become this is become the directed graph, we can write there. Okay, we can say this becomes we can say the directed graph there. Okay, so directed graph because from there and till and after it we can apply the like simply topo sort here, and like we have to treat these as a numbers, like A B C D as a 0 1 2 3. So like this is simply part there. And okay, so like so do this part here, like what's our approach from here. So like I have to write this part here. Firstly, what we can do here, firstly I have to write I have to make out the graph of size of K, means see there is a something given there's any of the chances, any of the some let's say there are the four characters given, but let's say if there are the characters are given as a 6 or 7, so in that case we have to find only the relation between the four characters. But there might be cases when let's say if I'm writing this, let's say if there is a 5 is given there, okay, so what it means there is some character also that is nothing but the E, so we don't have any relation between E, so there's E. Let's say there is a K is equal to 6, okay, let's say K is equal to 6, and there's again no relation between another character there, F, so this is nothing but the different component. So we also know like how to apply the topo short in different component, okay. So that's why firstly we have to like come to this approach part. We have to make our graph of the size of K. This K is nothing but the characters there. After it, like how to do this, we can compare wait a second, we can compare our adjacent words there, okay, we can compare our adjacent words there, and after it we can say if we have to find our first mismatch, okay, that gives me idea like what should be the ordering according to the aliens, okay. So we can say we have to add our edge is like U is come before to V, okay. So this is only done by using the topo short, okay. So simply apply topo short there, okay. We can use any of the topo short, like we can in here we can use our Kahn's algorithm, okay. So Kahn's algorithm is nothing but the topo short using the BFS, okay. After it we can convert our result into string, because we have to return our string format, so we have to convert this, okay. So that's our question given here, okay. So again I write like this is our words is array given here, so this is nothing but the words array, this is nothing but the total number of size of this array, and this is K is equal to nothing but the characters, unique characters behind this, okay. So what we need, we simply have to like see, we have to make the our graph from this. So what's the things behind this graph? So there's the nodes is nothing but the characters, and there's are nothing but the 0 to we can say K minus 1, okay. So these are our nodes, and what are our edges, like how to make its edges it is according to like what is the constant given in this question. So by this we can make our edge, there's our edges there, and like okay. So now come to this part here, and okay, so come to this coding part here. See here, see our main function is given here, where we have given our dictionary array there, there's a n there, and there's a key like a K words given there, okay. We use our vector int, this is for the adjacency list. So how to make this adjacency list, we simply traverse from the 0 to, since 0 to n, but we have to comparing I and I plus 1, so that's why this comes under the limit, so that's why n minus 1 there, okay. We compare what are the minimum length, because let's say there might be the some of the cases where it is like there's a 4 word there, there's a 3 word there, okay. To compare we have to only go for the minimum size, so that's why we take int length, there's minimum of whatever the s1 and s2 there, and after it we have to simply for this is loop goes on from the like okay. So what it means, we have to I for the comparing this, let's say this is our I, this is our I plus 1, okay. Now after it we have to go to deeper into this string, these words there, so that's why 0 to 0 j is equal to 0 to length there. Now check whatever the character we have to find, or we can say the first mismatch. If we are able, we simply put this in our adjacency list, so s1 of j in s2, push back s2 j, and since these are the we are stored the number, so that's why minus a, okay. And since we are able to find, so simply break, because we don't want another mismatch there, okay. By this our graph is made. After it we can simply apply our topo short, you know very well. If you don't know, I made my previous video where I explain how this by using the BFS, how using the DFS. So this is nothing but that we firstly take our in degree vector there, make out the update our in degree vector there using the queue, or whose over the in degree 0, simply push this in our queue, take our answer resultant vector, and till our queue become empty, take that node, pop that part, and simply add up this in our answer there, and goes to its neighbor, and its neighboring integer is updating, and how is it updating? It is reduced by the 1 there, and if it becomes 0, simply push this in our queue, and like simply this goes on till the queue become empty, and simply return the answer. Okay, so this gives me the final answer there. Okay, now okay, so these are the things here, but we also have to check, like there are the some of the things in which there are the not valid condition there. Means in this question it is asking me if what we have to do when we are not able to find any of the order here. So like on what are the cases, this is the thing here. So we can say, since this is a topo shot, okay, you know very well, like this is topo shot, this is only valid for the DAJ, mean directed acyclic graph. So what if we can say, we have to say, what if there is a cycle? Okay, we can say, what if cycle is here? So like how is the cycle? Let's say there are the words is given as A, then B, as C. After it we have to see B, then C, then D. Let's say this, let's say D and E. After it we can see E, then G, then F. Okay, now we see one thing, this is not possible. Like how, why it is not possible? Because if we comparing from this, so it gives me idea that A should comes before B. Okay, now when we comparing this, it gives me idea B should comes before A. So what it means, there is a cycling between A and B. Okay, so and since we know that topo shot is not applicable for the cyclic graph there, so that's way this is not possible. So this is the one case in which it returns there's a not order possible for the alien. There's another thing, another very important case I can say. There's a when this is one of the most important thing here. And what is the thing here? This is nothing but the, when let's say we have to compare our string, like this is A, then B, then C, and then G. Okay, after it let's say there is another string that is nothing but the A, then B, then F, then D, then R, let's say. Since we know normally, like we know that whenever A, B, then C, then D. Okay, so sorry, this is the thing here. See, I have to write, don't write this completely here. Okay, after it R there, and let's say there is H. Okay, see, we know generally, like whenever there is a ordering is given, like A, then B, then C, and after A, then B, then C, then D. Okay, so this is possible. It means that this the first mismatching is D, so it means this is possible. Like we can say, like I don't know why to use this. Okay, so if I'm talking about this test case, so this is nothing but the possible for it, so it is possible as usually. But if I'm talking about this case, let's say if I'm talking about this case, so here it is not possible because we are extending to its limit, because the upper one is at here. You can say this is not possible. And you know, like why it is not possible? Because when we are traversing here, so A, B, F, D are same, okay. Now we come to H, since we have to go for the only the minimum limit there. Okay, since it is, we have to go for the minimum size, so it means it doesn't track and about H, so it means it doesn't give me the idea behind this, and it is not possible here. Okay, so we have to find so there are the two cases here, either of this or either of this. Okay, so it means if there is no mismatch, we have to simply ignore. And if our topo shot size, we can say finally our topo shot size, if it is less than K, it means there is a cycle, so this is also the invalid case. Okay, so we have to keep sure about these two cases there. And like how to write this part, this is also similar. Like what we have to do here, we simply take the one extra cases here, like we have to count this. Let's say we have to simply check, this is a length 1 for the S1 word, and there is a int length 2. Let's say there is a length 2 for the like we can say for the S2 part here. And after comparing, if we see, let's say we have to loop our like we can say, while our S1 of I it is equal to S2 of J. Okay, sorry, it is nothing but the, I read the wrong thing here. Oh, sorry. So okay, so this is nothing but the j, and there is again the j, or what is the j? It is nothing but the j is equal to 0. Okay. So if till this is continue, so because we have to find the first mismatch here, and till here we have to simply update our j plus plus here. And if we see, if our j, it is given me the min length, okay, and in this case when we have to finding the min length is not the same here, so in that case also we have to return. Okay, like comes to this part here. Okay, so in that case, let's say I have to write this part here. See, this is the thing when, okay, so this is for the valid case here. Let's erase this part here. Okay, so like what's the thing here, we have to compare our s1, and this is for the s2. We have to compare the what's the minimum length. Now we see, let's say we have to use our bool vector, which is of the found is with false. Now traverse our inner loop, j is equal 0 to length. Now check whether when if any of the if not equal there. Okay, simply push this in our adjacency. Okay, now if this is the case when we are not able to find any of the case, means bool is remaining the false, and if s1 size is greater than s2 size, this is the case when I'm discussing about this. So this is on, in this we have to return this empty string. Okay, this is the question given. So this is the thing, like I don't want to write this part here. Okay, so I have to explain you like in which cases this is falling there. Like I have to simply erase that part here after it. So this is for the like okay, so like this is the code there. Now coming for the what's the time complexity, I think like you should understand. Coming to the time complexity part here, so let's discussing this part here. Let's wait here. So what's the time complexity for it? So its time complexity is nothing but the of n into L, we can say, plus k plus e there. Okay, and coming for the space complexity, it is nothing but the of k plus e. Okay, like how to do this, like how I say this part here. So see, this is n into L. L is nothing but the, it gives me the length there. Okay, so like firstly you know the what's the time complexity for this topo shot, so I skipped that part here. Coming to this part, during the building of this graph there, so we know one thing, like how to do this part here. We simply go over and loop here, and for the I is going from the 0 to n, and for it goes to the L, so that's why n into L comes from it, and this k is nothing but the number of node. And we simply know like for the simply topological short time complexity is, it is nothing but the of v plus a, and you know very well like v is nothing but the vertex, but for this question there is for the topo short the vertex become k, so that's why it is nothing but the k plus e. So that's why this is our time complexity, n into L plus k into e, and space complexity remain the same, k plus e. You know like why it is, because we are using this adjacency vector extra here. Okay, and okay, so and this this is, you also know like in my previous video you can see that like I have to explain what's the time complexity, space complexity for the topological sort, so same applies for this question. So thank you.